Hey guys, welcome to the video on modeling with parabolas. I want to start with a little review of linear and exponential models, and then we'll jump into the new quadratic models, which are parabolas. So, little review. Linear models, the pattern is adding or subtracting to get from value to value. Okay, that had to do with slope. So how much do you rise over run, add or subtract from value to value? And the equation we all know and love is y equals mx plus b, where m is the slope and b is the y-intercept. And then a graph is just a line. So I don't know, let's say we had a positive slope, something like that. All right, so that's linear. Now let's jump into exponentials. To know if a model is exponential, it was a multiply or divide pattern. Multiply or divide pattern. That was exponential. The equation for exponential is y equals a times b to the x power, because it's an exponential. A was the initial y-intercept value, and b was the growth or decay factor. And then what does an exponential graph look like? Remember, let's say it's a growth. It starts off low and then it grows exponentially. It's a curve like that. But we're done with those, and we have moved on to quadratic models, which are called parabolas. Now, the pattern for a parabola is the graph, it turns. So let's say it could be that it's increasing, and then it turns around and starts decreasing. Or it could be vice versa. It could start decreasing and then turn around and start increasing. So there's always a turning point to a parabola. Now there's two equations. One of them is called standard form, and one of them is called vertex form. And we'll spend time on both. Standard form is y equals ax squared plus bx plus c. And then vertex form is y equals a times x minus h squared plus k. And we'll be spending a lot of time on both. And then a graph of a quadratic parabola would be something like that. Okay, so it turns around. Another way, it could be upside down, and maybe it looks like that. Okay, but there's always a turning point, and it turns direction. All right, let's try a couple applications to see if you guys can read graphs of parabola and determine what they're asking and what they mean. So feel free to pause this if you want and try it. But number one, saying the height of an object above the ground is given by this equation, where t is time in seconds. And then height is meters. What is the maximum height reached by the object? All right, so here's our starting value. The object's going up, 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 up. Okay, this is the highest it goes, and then it comes back down and hits the ground. Okay, so the answer for A, what is the maximum height reached by the object? It's going to be the y value here, 164 meters. That's the maximum height. Now B, how long does it take for the object to reach that maximum height? So that's saying, like, how much time has passed before it reaches the maximum height, and that's going to be the 2 seconds. Now C says, when does the object land? So it goes up and then it comes back down. When does it land? The time? That's the 5.202 seconds. Now D says the object was launched from a platform. How high was the platform when it was first launched? That's this one here, the starting value, the y-intercept. And that's at 100 meters. And then E says, how long was the object above 100 meters? Okay, so let's find the two spots where it's at 100, right? That's at this line here. That's the 100 line. How long was it above there? How many seconds have passed? So from here to here is how many seconds? That's 4. Okay, so the answer is 4 seconds. Okay, so pretty easy. It's just reading a parabola to get information. If I were you guys, I would pause it. If you feel good and want to stop, go ahead. I'm just going to do one more. This one is about a dolphin diving. So the dolphin is diving underwater and then it resurfaces back to water level. Okay, but feel free to stop here if you want. What was the lowest the dolphin dives below the water? So the lowest he ever gets is here at -100, and that's meters. Okay, below water, negative. B, how long does it take for the dolphin to resurface? All right, so if this is time 0, this is when the problem starts at time 0, and by the time he resurfaces, that's right here, it's saying how much time has passed, and that's this guy here, 8.472 seconds. C, at what time does the dolphin reach its maximum depth? So here's the maximum depth. What time was that? That's going to be the 4 seconds. D, the dolphin was swimming underwater before it started to dive. At what depth was the dolphin swimming before its dive? So that's going to be time 0. Where does the problem start? How deep is he? And that's the -20 meters. E, at what time did the dolphin reach a depth of 80 meters below? Okay, so now here's 80. What times did he go down to 80 meters below water? It's going to be here and here, so that's at 2 seconds and at 6 seconds. So 2 seconds on the way down and 6 seconds on the way up. And then last one, how deep was the dolphin after 8 seconds? So go to 8 and travel down, that's right here, and that links up with 20 meters below water. Or you guys could just put -20. All right, nice job, guys. That's modeling with parabolas.